had to start the recording. So thank you all for joining us today. So sorry for the delay. We've had a little bit of technical issues, but hopefully we are good to go now. My name is Katie. I am with the NOAA Central Library. We are bringing you this presentation today through GoToWebinar. GoToWebinar does have some technical difficulties. If you find yourself not being able to see the slides or not being able to hear us, please try logging off and logging back on. That solves most issues, not all. So we are recording this, and if you miss any piece of it, have to step away, or would like to share it with a colleague, the library will be uploading this to our YouTube channel later. Also, we are going to hold all questions until the end of the presentation. Please bear with us through any technical snafus. With that, I'm going to turn it over to Lee to give our introduction today.
Great, thanks so much, Katie, for making this possible. Appreciate your time and effort and everything the library does to share science, and in this case, art and music with the NOAA community. My name is Lee Benica. I work for the National Observer Program at the NOAA Fisheries Office of Science and Technology, and I kind of focus on bycatch and bycatch estimation issues normally. I got an email out of the blue from Annie Lewandowski back in February asking if she could talk to me about bycatch, particularly marine mammal bycatch or gear interactions. So always happy to talk about bycatch, one of my favorite topics. So we ended up talking, but before that, I saw her email message and it had a few links on the bottom, and I quickly clicking on those, I found out that she's a musician in a really cool band, which was awesome, and that one of her band's albums covers was illustrated by a pretty mysterious cartoonist that I'm a huge fan of. So that was also very cool. So we had bycatch, music, and cartoon art. It was kind of a nerd trifecta for me. I was very excited to learn more about what Annie's doing and get to know her a little better. So we had a nice conversation. I think I pointed her in some directions to get some more resources, and I found out several months later that she was able to put together with her colleague Kyle McDonald a pretty amazing installation that involved music, particularly whale songs, and visuals and coding and artificial intelligence to create a piece that conveyed an important conservation message about the importance of marine mammals and the danger they face from derelict fishing gear. So I won't say any more about it because we're going to hear a lot more about it over the next hour. So thanks everyone for joining us, and ask Annie and Kyle to take it away. Thanks.
Thanks so much, Lee. It's really a pleasure to be here. I'm Annie Lewandowski, and I can't get my camera working, so I will be in the dark here, but I do have a presentation which I can show you. Lee and I had a series, as he said, of really important and really project-defining exchanges early in 2021 as Kyle and I were beginning to explore marine entanglement for our project Siren, which we'll be talking about today. So huge thanks to Lee. And thank you also to Katie and NOAA's Library Seminar Series for hosting this event. Kyle and I are going to present for 35-40 minutes and then leave the remaining time of the seminar for a Q&A at the end. So in 2017, I began meeting with pioneering bioacoustician Katy Payne to learn about the changing songs of humpback whales. Katy had visited a class I co-teach at Cornell University with Ron Hoy called Music on the Brain to talk about acoustic communication in another species, and had given a wonderful lecture on her discovery that the humpback song evolves over time through horizontal cultural transmission. I teach classes in the Department of Music in songwriting and improvisation, and I found with humpback whales a kind of kinship. The creative process I was involved in and was researching in humans revealed to me in another species. In meetings with Katy, we listened together to the songs of Hawaiian humpbacks from the 1970s and 1980s, marveling at the timbral and expressive range of the singers. We analyzed and compared songs and talked about changes we noticed in the song's composition over time, changes that changed from really quite nuanced to really bold. These rich listening sessions and conversations inspired me to compose Cetus, Life After Life for whale song and chimes. In Cetus, the chimes perform in duet with recordings of two Hawaiian humpback solos played in sequence, one from 1977 and the other from 1981, which is a time of really remarkable innovation in this humpback population song. The chimes part I composed follows the development of one of the song's themes during this period, tracing its changes over the course of the piece. So I'm going to play for you now just a brief excerpt just to give you a little bit of an idea of where I'm coming from in my entry into all this work. And hopefully you'll be able to hear it well. So in 2019, Katy and I traveled to Hawaii with funding from the Atkinson Center for Sustainability to record humpback singing during the height of the breeding season with the Hawaii Marine Mammal Consortium. Not knowing what the field research experience might reveal, my aim was simply to listen and to record as much as possible. The listening experiences were beyond anything I had previously known. On our first day in the lee of Hawaii's Big Island, the four of us, Dr. Adam Frankel, Chris Gabriel, Katy, and I ventured out into an 18-foot Boston whaler in really pristine conditions. There's no wind, no waves, sunshine, and blue sky. A short distance from land, Adam Frankel, one of the scientists on board, suggested we cut the motor and that we might be able to hear the singers above water. As the sound of the motor diminished, this slight crescendo rose from the hull of the boat, and totally inconceivably to me, the rich song of humpback singing in the waters beneath us was resonating the hull of our boat. We sat still together, listening silently as the song swirled around us in this really remarkable listening experience. So this immersive experience listening extended to another medium in Hawaii while swimming in the ocean, kicking my feet up in the air. While underwater, I experienced the feeling of being completely enveloped in the humpback song, a feeling like I was inside of it. Listening in the water created a loss of directionality and a loss of the high frequencies of the song, but the low frequencies, when close enough, could resonate a person's body. These listening experiences would come to inform the sound design and the immersive experience of the piece Siren. After 2 weeks on the water together, our recordings ranged from distant choirs of humpbacks singing asynchronously to really detailed recordings of singers close enough to our boat that the Hawaii Marine Mammal Consortium was able to take photos of the singers' flukes, which function as a humpback's fingerprint. No two are alike. These here pictured are the 3 humpback singers we recorded in Hawaii that are foregrounded in the installation Siren. Humpback song contains a variety of note-like units that are organized into repeating groups called phrases. Phrases of one kind are grouped together to create themes, and these themes are sung in an unvarying order that then repeats, often without pause, for hours on end. The population song during the time we were recording in Hawaii contained 5 themes, and I'll play for you now excerpts of these soloists singing the themes that made up the population song. So this recording of Humpback's song was really wonderfully detailed through the combination of the expertise of our Marine Mammal Consortium collaborators and a stroke of good luck when our hydrophone, which is an underwater microphone, revealed that he was singing quite near our boat. So here's an excerpt first of him singing theme 1. So this singer stopped a really dazzling performance mid-theme 2 to begin an active surface display of breaching and peck slapping, which you see pictured here. This recording captures that moment and when theme 2 ends and then he appears above water. So whenever I listen to this recording, especially at this very moment when the singer drops out, it always sounds to me like the oceanic abyss suddenly revealed. Another humpback soloist we recorded for nearly 2 hours, drifting into shallow enough waters that the sounds of snapping shrimp took up significant real estate in the oceanic soundscape. The shrimp are the bacon sizzling sounds you hear in the recording. Here's an excerpt of theme 4. And then here's an excerpt of theme 5. And the final soloist of Siren riffed and played with the material of theme 3, adding inventive new gestures not otherwise heard in our recordings from that period. Though singing a similar song, each singer invariably sings it freshly his own, with changes revealed in aspects of both time and tone. So we'll listen now to each soloist's unique take on theme 3. So here's the soloist that was just pictured. And the second soloist. And the first soloist. The Siren installation, pictured here, both at Cornell University at the Johnson Museum of Art from the Whale Listening Project in September, is in the blue light, and from a preview on Martha's Vineyard in August in the outdoors, developed out of the collaboration that Kyle and I began just over a year ago, which grew to include scenic designer Amy Rubin about 4 months ago. It was commissioned by Media Art Exploration in New York. And as Kyle and I listened and re-listened, both alone and together, to these humpback soloists, our aim became focused on illuminating the unique voice of each humpback whale composer. We found that over time, as our ears became increasingly sensitized to each soloist performance, more and more variety was revealed to us in the details of the song. So we began developing Siren as a piece that guided listening through the song structure, comparing singers. I sifted through several hours of the recordings I made in Hawaii, choosing ultimately the clearest and most detailed recordings of these three soloists to analyze with Kyle and to organize the sound design around. I used a software developed by the Lab of Ornithology here at Cornell called Raven, where I manually annotated or tagged each sound unit of the song, assigning similar sound units the same label. These manual annotations I then shared with Kyle for machine learning analysis, which he'll talk about in a moment. As Kyle and I were exploring the interior creative worlds of humpback singers, we were also exploring the exterior worlds of humpback whales. And this is where I, started this conversation that was really fruitful with Lee. A major contemporary issue, as many of you know on this call, I'm sure, in conservation is marine entanglement, which senior scientist from Woods Hole Oceanographic Institute, Michael Moore, calls unintentional whaling. Here in the Northeast and the Gulf of Maine, 70 to 85% of humpback whales and North Atlantic right whales show signs of entanglement scarring. Entanglement is one of the leading causes of death for North Atlantic right whales, one of the world's most endangered large whale species, now numbering under 400. The Siren sculpture you see here in the photos is constructed from 200 pounds of net and rope waste and debris removed from the ocean around Cape Cod. In April and June of this year, I traveled, since I'm not pictured, that's me in the purple jeans there. In April and June of this year, I traveled to the Center for Coastal Studies in Provincetown to retrieve derelict fishing gear with Laura Ludwig, the coordinator of the Marine Debris and Plastic Program. This work was also supported by the Atkinson Center for Sustainability. The Center for Coastal Studies removes between 8 to 12 tons of debris from the waters around Cape Cod every year. Laura Ludwig notes that data reflects that very few large whale entanglements occur in ghost gear, which is any abandoned, lost, or otherwise discarded fishing gear. Studies on entanglement show active fishing gear to be the source of entanglement or are otherwise inconclusive as the origins of the entanglement material. So Siren invites the audience into the tangle to consider how we can use technologies in a way that escapes their connections to extraction, to provide instead protection for our ancient marine mammal relatives. Siren will be shown next at the Neuroverse Festival in New York City, November 5th through 7th, which is going to be at New York Live Arts. And with the festival is with Siren located at Brooklyn's Invisible Dog Arts Center. This weekend of events explores the intersection of neuroscience, machine learning, and AI with artists and creative technologists teamed up with scientists to meld theater, dance, audiovisual installation, and lectures. So if you're interested in learning more about it, you can look at the Media Art Exploration website. I will now, before I kind of pass the mic to Kyle, I would like to show you two brief excerpts of Siren. The first from Martha's Vineyard, and then the other from the Whale Listening Project at Cornell University. So here is the Martha's Vineyard. Okay, and then finally the Cornell University installation. And I should say that both of these can be found on YouTube if you Google Siren, listening to another species on Earth, which will offer you undoubtedly a better visual and sonic experience. So I'll end there and we'll pass the mic to Kyle. Thank you.
All right, can you hear me? Great. So my name's Kyle. I'm an artist working with code and sound, and I'm based in Los Angeles, and really grateful to Annie for the amazing setup and to everybody who helped organize this. I wanted to walk you through some of my involvement in the Siren project that led to the lighting design, which you saw a little snippet of there. So how about this? Do you hear that? Okay, great. So we've got audio. So the lighting design for Siren's an evolution of a technique I've been exploring for over 5 years. In the field of machine learning, there's this technique called nonlinear dimensionality reduction, and I use an algorithm for this called UMAP. UMAP will take a big data set and lay out every data point in space so that similar points are closer together and dissimilar points are farther apart. In this case, in this picture, the data set is handwritten digits. Each digit is a tiny image, 28 by 28 pixels, which you can think of like 784 numbers. So UMAP reduces these 784 numbers to 2 dimensions, and we plot an image at each of those spots. You can see the 9s kind of blending into the 4s. If we zoom out, we can see that UMAP can automatically figure out that there are kind of 10 digits with some of them blurring into each other. We could also use tiny images of ancient Japanese characters with each character type clustered into their own region, or tiny images of fashion items with all the high heels forming this cluster at the bottom right and the boots to the top left. UMAP and other algorithms like t-SNE can suggest a shape to a data set that's sometimes hard to see from just looking at an individual data point. I first explored dimensionality reduction in the context of short drum samples. I was thinking about the kind of new ways to explore large sound data sets for composition and improvisation.
Welcome.
Hello.
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 So I doubt this is going to come through very well, but basically as I scroll along here, then you can hear different sounds in different places. I showed this tool to a friend, Alexander Chen, who recently moved to rural Massachusetts, and he was quickly turning into a bird watcher, or as a friend, Jenny Odell, likes to call it, a bird noticer, and asked what would happen if we used bird calls in this system. So I split up a bunch of calls and songs in a data set from the Cornell Lab of Ornithology that included North American birds. Processing sound with UMAP is similar to working with tiny images. I just make a tiny spectrogram representation for each sound. And we can snap these spectrograms to a grid to navigate them more easily. After working with Alex on the bird calls, he got in touch to ask what we might be able to find in a much larger data set of underwater recordings. He'd connected with researchers at NOAA over a large, I think it was 7 terabyte data set once it was all compressed down from these devices called HARPs. high frequency acoustic recording packages. It's called high frequency because the audio is originally recorded at more than 100 kilohertz and then sampled down to about 10 or 16 kilohertz for analysis, or the analysis we were doing at least. They're typically deployed about 400 to 900 meters below sea level for months at a time. And to save power, a harp will alternate between recording and sleeping. So it might be recording for 75 seconds, followed by sleeping for 15 minutes, which means you get all these little snippets of what's happening underwater. The data I had access to was recorded over a 12-year period, and if you put all of the recordings back to back, it would take, I think, 15 years to listen to all of it. If you hadn't seen spectrograms before, spectrograms are just visual representations of audio where time kind of moves along on the x-axis and then frequency is on the y-axis, and the darker or lighter, or the way that the color changes, that corresponds to how much energy there is at that time and frequency. So a rising sound might look like a line that goes from the bottom left to the top right. A falling sound would go to from the top left to the bottom right. A quick clack would be a kind of vertical line, and a sustained tone would be a horizontal line. There's a little bit of everything in the harp data. If you listen to it for long enough, you can hear, well, I'll just play a little bit. If you can't hear that audio, there's also a link in the chat, which includes a link to this video that you can check out later. You heard a little bit of everything from Navy sonar and echo sounders to dolphin whistles and sperm whales and fin whales. How can we listen to 15 years of recording? This is this is a place where different kinds of visualization come into play. It's an opportunity to look as well as listen. So one technique for this is called long-term spectral averaging, LTSA. There's a recent example here from 2007 by Wiggins and Hildebrand showing an LTSA over 2 hours on the left, and then 3 images that show excerpts from different times in that 2-hour period. I think it's dolphin whistles, dolphin clicks, and 50 kilohertz echo sounder, creating that kind of pulse over time at that 50 kilohertz mark. I started exploring this data set by recreating some of these LTSAs. This is what a humpback song looks like when you really zoom out over, I think this is probably a 30-minute period or more. I made some additional modifications like using color to indicate the frequency of repetition. So red sounds are repeating slower and the green sounds are repeating faster. Because humpback whales seem to keep an even tempo in their songs, this visualization helped me see where more than one whale was singing alone. So if you have 2 at the same time or more, and they're all being recorded, then you'll see these different kind of overlapping colors. I expanded this technique to a whole year of audio, but it becomes impossible to kind of dig into what a whole year looks like when you want to see it all at the same time. But we took that year of audio and made a website called Pattern Radio with Alex as part of his role at the Google Creative Lab, and it lets you listen to a year of harp recordings. And through that project, I met Annie. So she provided a guided tour for the recordings, and she got in contact with me to see if there was some way we could collaboratively explore recordings she made with Katy. This is one really long spectrogram from one of the singers featured in Siren, read from top left to bottom right. For Siren, I wanted to return to an idea from Pattern Radio. Instead of chopping recordings into individual units like the bird calls, like every short sort of syllable or phoneme or unit that they sound, I chop them into small, evenly spaced chunks that just kind of progress over time. And then when we embed these chunks, they create paths through a space over time. After, like, a repeating 3-unit phrase turns into a circle with some slight deviations when there's a slight deviation in the units or the vocalization. 2 repeating units turn into, or 2 sets of repeating units turn into 2 circles with transitions between them. And the colors beneath the spectrogram correspond to, instead of a 2-dimensional embedding of these sounds, it's a 3-dimensional embedding in a 3D color space, an RGB color space. This was building on some of the research that Annie mentioned before from Katy and Roger and some other researchers trying to understand the hierarchical or hierarchical structure of humpback whale song. Other researchers, serious bioacoustics researchers, not me, not artists, create transition diagrams that correspond to songs like Ellen Garland. But I'm less interested in kind of answering a question or making a judgment about these recordings or what humpbacks are doing. I'm more trying to craft like an evocative gesture that pairs well with the listening to the composition and exploration of what it might mean or how you feel about it. Something for developing an intuitive appreciation rather than an academic understanding. If we extract each of the units individually, we can also observe the gesture of each unit. Some are more chaotic, where the kind of individual moments of sound sort of jump around, and others are more linear, like very focused loops that return back to where they start. The only way to do this was with some help from Annie, who hand labeled all of the units. So this was that spectrogram I just showed, and then this is what it looked like once Annie got through with it, deciding how to categorize each one and determine the beginning and ending of each unit. That allowed us to make something that looks like this, where we can see these gestures evolve over time. So each of these 3 singers have their own way of performing the song. If we extract all of those units from each other and separate them, we can see that there's some similarities between the different singers and their song performances. We can overlap them back on each other, and we can see that some of the units are performed very differently by some singers compared to others. So at the bottom left, the F unit, which is that low growl, that fills out this kind of different acoustic space for the singer in green than the 2 in red and blue. So that process of mapping from the sort of spectral content to this spatial layout and then to a color space, this led to the final lighting design for Siren. So this is a representation of the lighting design that we use that corresponds to the audio. And in this case, it's going from the top left down, and then next to the right, and then down, and then next to the right, etc. With the machine learning algorithm UMAP basically identifying different unique colors for the different sounds, so that similar sounds have similar colors and dissimilar sounds have dissimilar colors. So this is the whole process I just mentioned. So to recap, we start with these spectrograms. Annie annotated all of the units, and then we used UMAP to map these sounds into 2-dimensional gestures for each type of unit. And then these gestures are mapped from a 2D space to a color space, and then these colors are used in the final piece. And my hope with these visualizations is not just to produce some kind of beautiful images or lighting. We're not just trying to like make people feel like at home in the installation, but to give them something to reflect on, to kind of explore visually in concert with machine intelligence. in a way that allows us to listen more deeply to our ancient relatives. Thank you. And I'll go back to the group.
Great. Thank you so much, Kyle and Annie. We do have a few questions, so I'm going to hop into those. The first one is actually for Annie. There was an asking, was one of the clips a soloist? So was the which whale was featured in the sound clips of the Siren displays?
Yes, so in the Siren displays that you heard, I think it was, I believe it was the one that it was just before the snapping shrimp got involved. It was the second soloist that are in the excerpts. But yeah, there are 3 soloists that are foregrounded, and it was interesting. A few weeks ago at the Whale Listening Project at Cornell, which was this 4-day event celebrating the beauty and conservation legacy of songs of the humpback whale, with the record Songs of the Humpback Whale on its 50th anniversary, with the co-producers Roger and Katy Payne. 2 of the scientists that I recorded with were there, and they actually helped Kyle and I to get to know these individuals better. They had traced them on Happy Whale, which maybe some of you out there are familiar with, but we learned about their migration paths. And so we've come to know, actually seems like, quite a bit about these 3 individuals. We spent a lot of time with their recordings and now know a little bit about areas that they frequent, kind of off of the west coast of Canada and up in Alaska, and then around Hawaii.
Thanks so much, Annie. Okay, so our next question is actually for you, Kyle. What is the X and Y axis for the circular graphs? The circular for the whales repeating, big blobs for the bird song. Could you expand on that?
Sure, yeah, so there's no meaning. It basically, when UMAP or TSNE tries to lay out some sounds in space, it's kind of like you just gave it a table and you said, here are all the sounds, can you kind of put them on this table? The table itself doesn't have any dimensions or meaning to each direction. You could rotate it, you could kind of skew it or stretch it, it's all the same. So it's more like trying to solve an optimization problem rather than trying to interpret in a literal or like a way that maps directly to some features of the audio. There's other kinds of dimensionality reduction algorithms that tend to extract more meaningful features or interpretable features on different axes, but UMAP is not typically one of them. Yeah.
Great, thanks, Kyle. I don't have any more questions from the audience. Lee, do you have anything you would like to ask?
Why, sure. Thank you, Katie. I was wondering, I guess this is for both Annie and Kyle, what are some of the more memorable responses you've received from people who have experienced Siren? And this could be in terms of the artistic aspect or the conservation implications, just anything that's really stuck out to you, please.
Well, I talked to quite a few of the staff from the Johnson Museum of Art, where Siren was recently, and I think it's a complex show to take in, and what people who had come at the museum to visit, like they're drawn to the room where Siren was installed because of the songs, and they were so beautiful. And I think this is what kind of Kyle and I intended, and you're just watching in this kind of display, this amazing lighting display that really kind of helps you understand the intelligence behind the songs, but you're seeing it projected on this material that is actually, and I brought back 700 pounds of material. Like there's no end to the amount of debris I could have collected those 2 trips, it seemed like. And so I think I talked with, I couldn't kind of paraphrase very well this one response, but it was good for Kyle and I think both to hear, because we're kind of trying to 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 kind of be in the complexity of the moment, which there's this beautiful song and enjoying it and its kind of power, and then also kind of this total puzzle, which many of you perhaps on this call are engaged with entanglement and bycatch, and kind of thinking about solutions. So I think having someone respond with the kind of feeling the complexity of the situation and feeling all of the beauty, but all of the despair also was a really great response to get. How about you, Kyle?
One of my favorite reactions was at the Johnson Museum. We installed this speaker on the roof so that the sound kind of reverberated throughout the entire campus. And just after we set that up, I went outside and just went to the kind of street level and hung out there and made sure, you know, this isn't too loud or too quiet. And someone was walking their dog, and the dog went. Yeah, it was very interested in the humpback sounds, and that was one of my favorite reactions to the piece. A lot of good human reactions too, but I think I love seeing how the other creatures around us kind of feel about this too.
Thanks, Lee. We did have a few questions come in while you guys were answering that. Kyle, do you have a link for the UMAP or how even you spell that?
Yeah, totally. So in that tinyurl.com/siren links, there is a link to TSNE and about TSNE, which is very relevant for understanding UMAP. UMAP is spelled UMAP, and it was created by a kind of topologist, mathematician named Leland McInnes. And I'll also add a link to that document for the UMAP repository on GitHub, which will be a way that you could use it.
Great, thank you. And Annie, do you recall the project you mentioned, mapping where whales go according to what folks picked up on hydrophones? Do you know what that project is called, or how people could get more information on that?
Where whales go? I don't know about that, but the happy whale that I was talking about is
Okay.
happy whale is the one where I think that's all based on fluke ID. And so scientists basically log that, and then there's sort of this trail of where these various humpbacks have been found. But I personally don't know about song being used to identify individuals at this point.
Okay. Thanks for that question. I have put a link into that happywhale.com, and yes, it is the you can submit images and browse their data for fluke prints. Well, I think that's the end of our questions. I want to thank everyone for joining us today. Thank you, Annie and Kyle. I apologize for any technical snafus that we had today. I still think the sound came through perfectly, and your presentation was, as I quote someone who put this in the question panel, outstanding. So thank you for this outstanding presentation. And just a reminder, we did record it. I will do a little magic behind the scenes and get it up on YouTube for everyone to share.
Can I say something?
Mm-hmm. Yes,
something
please,
quickly,
Annie.
which I just want to say, like, it was so great for me that like Lee and NOAA was so responsive to having a conversation, because that was really had a powerful impact on the work that Kyle and I did together. And I know that it can be easy for many of us to kind of stick to our disciplines, and I just really appreciate the receptivity to collaboration and to sharing information in this way. And it's just really had a powerful impact on the work that Kyle and I are doing. So thank you, Lee, and thank you more broadly to NOAA. Really appreciate it.
Yeah, 100%. Thank you so much also.
Yeah, I'd like to echo that too. You know, getting to talk to people like Annie and Kyle makes me appreciate what a really cool job my job is at times. So, you know, hearing from Annie initially made my day. It was very exciting, and it's wonderful that we've gotten to this point, and look forward to hearing about what you both will do in the future. And hopefully NOAA can help out if you need it in projects to come. Thanks.
Yeah, I hope to see you all in Brooklyn, November 5th through 7th. I posted a link to the Siren installation there if you're able to attend.
Wonderful. Thank you all. I hope you have a wonderful and safe rest of your Thursday. Thank you.
See you later. Bye.